Okay, so my name's Envoy. I'm a software engineer at IBM. At least I am for the next 2 weeks. I'm joining a startup in 2 weeks called Tetrate, and we're going to be doing kind of multi-cloud and hybrid cloud application management, leveraging things like Istio and Envoy to basically allow you to look at your entire applications across multiple kube clusters, it doesn't even need to be kube clusters, it can be like on-prem things, monoliths, that type of thing, but all kind of in a unified place. In terms of Istio work, I think I've been working in Istio for probably about 2 years now. So because obviously I work at IBM, we kind of knew about it before it was announced because it's a joint IBM-Google project. And I was looking for something to do and kind of came across Istio and thought, this seems like it could be very big and quite a useful thing. So I'm started contributing. I'm a maintainer, or kind of equivalent of a maintainer. I don't think we have that exact term in Istio, but I'm jointly responsible for like a subsection of the code, specifically around debugging. So if you have any complaints about the debugging experience, come speak to me because I'm interested in hearing them. I know some people have heard of it, so if you've kicked the tires and kind of had trouble debugging it, then come speak to me about your experience, because we know it's not where it needs to be, and it's kind of an early project, so we're looking at kind of improving that experience. So what is a service mesh, and how did we get to a service mesh? Well, we used to do things like this, monoliths, right, where pretty much all of your calls are function calls within the monolith. You have maybe 1 or 2 network boundaries, usually to a database, and usually from the user to the monolith in the first place. And so with those network boundaries, there wasn't too much concern with network reliability, with only 2 of them anyway. But when we moved to microservices, we added a load more network boundaries everywhere, right? And network calls are fundamentally less reliable than function calls. If your programming language had the same latency and error rate as a network call, for a function call, no one would use your programming language. So when we moved to microservices, this became more of a concern. And the more boundaries, network boundaries we have, the more things we have to deal with. So we have to deal with the latency and failures. We also have to deal with malicious attackers. Now, we kind of have to do that with function calls, but it's much harder to attack a function call than it is a network call. And the other thing with visibility, when you add all these network boundaries, it's much harder to see into your application and see what's actually going on and where the interactions are failing and that type of thing. So to solve a lot of these issues, we use things like in-process client libraries. These are a few that you might have heard of. Most people end up writing their own actually. The idea here is that these are all in process, so they're part of the application, and that you build them into your application and you deploy them as part of your application. And to call out or to leverage this functionality, it's all kind of an in-process function call. And they actually do a pretty good job of handling things like latencies, so making sure there are timeouts, handling retries and that type of thing. But fundamentally, you can't put this client library everywhere. If you're using things like Redis or Kafka, you can't put any of these client libraries in there because you don't control that code base. So if you can't do that, then you've got no consistency of all of this functionality. So the Kafka protocol or the Kafka client you're using might have something else. You might be using something like another team in your company's written that you want to leverage, and they use a different language, right? So if you're using like Finagle or something, and they're using Go to write whatever they're writing, because Finagle's Java only, you can't just say, oh yeah, we just want you to rewrite this all in Java for us, please, and use this client library, right? You can't just go around and tell other teams to do that. So without this consistency of client everywhere, we've got no guarantees that the functionality is going to be the same, the configuration methods are going to be the same, or that the telemetry that all of these things expose are going to be the same. Because I guarantee you, if you looked at the telemetry the gRPC exposes and Hystrix, they're all completely different formats, they'll have different names for the same thing, and it just gets, you then have to convert that all back into the same thing and process it all back into the same thing in order to be able to leverage a lot of it. And the only way we can really provide this functionality is part of the platform itself, right? In client libraries, if in some utopian world you could enforce everyone use the same client library, then you could get the same thing. But failing that, which I would say is impossible, you have to build it into the platform and do the right things out of the box, right? So how do we take this functionality and kind of, it's in the client library at the moment, it's in process, we write it into our code and we deploy it as part of our code. We need to take the kind of the same functionality that's there and we need to move it to the platform itself. So how do we go ahead and do that type of thing? And the answer is basically we use reverse proxy everywhere. And this is kind of what service mesh is. It's basically just a reverse proxy in front of each of your microservices. It runs as a separate process, so it's what's called out of process architecture. So these are running as separate containers within a Kubernetes pod. If you're using Kubernetes, they might just be running as separate processes. I would argue that containers and separate processes are kind of the same thing under the covers. But it all depends on what you're deploying to, right? If you're Kubernetes, these will be 2 containers within a pod, kind of using the sidecar model, if you're familiar with that. So the idea of a service mesh is that your code requires no modification in order to be able to leverage all of these features. Your code, as long as it's speaking some kind of thing, something over TCP, will be able to leverage all of the abilities that the proxy gives you. And the other idea is that it's completely transparent to your service. So if service A is talking to service B, normally in a Kubernetes, I'm going to speak a lot in terms of Kubernetes because that's kind of what most people use with Istio, and that's where most of the dev work goes on, but we do spot other things. But in Kubernetes, if you're talking service A to service B, as far as they're concerned, even in a service mesh, they're talking directly to each other, but they're not. This stuff's being intercepted. So what happens is when it makes a request that it thinks is out to service A, we reroute the request through the proxy. That proxy then will proxy the request onto another proxy, and that will then forward the request onto service B, right? And this here is typically going to be a pod boundary in Kubernetes. I don't know if you can see kind of what I've learned already is that I need to do more high contrast backgrounds on things, but this is basically a pod boundary here, and this is basically another pod boundary here in Kubernetes terms. So you've probably actually done something similar to this before, like traditionally with something like Nginx. If you maybe chop this diagram in half, so it's just here, you have your front door to your entire monolith, and you have your service running behind the thing. And the idea is it's kind of the same thing, kind of like an API gateway would be for a monolith, but you stick it in front of each microservice as your request goes through the request stack. Now, the reason we need something like Istio is typically if you were writing like just that with your front door and your monolith, you would write an Nginx config by hand. If you've got hundreds of microservices, you do not want to be writing all of this config by hand because you will never get any actual work done. So like Kubernetes does with containers, right? Kubernetes is a container orchestrator and it kind of automates all that process. We need to do the same thing with proxies. And this is where Istio comes in. Istio is basically just a proxy orchestrator, right? There is some PKI, so public key infrastructure, that we also offer, but fundamentally we're kind of like Kubernetes is to Docker, we're kind of Istio to Envoy is kind of the same thing. We're just responsible for actually orchestrating all of these proxies. So the idea is Istio abstracts away from actually configuring all the proxies and the deployment of the proxies, so making sure all of the proxies are where they should be within your mesh. And all you really should, once Istio is installed, all you really should be concerned, again, with the transparency in mind, is deploying your services within Kubernetes, and Kubernetes will just make sure that the proxies are injected for you. So, like Kubernetes, where I'm going to mention Kubernetes a lot, but the idea with Kubernetes is the model is it's declarative, and you talk to an API, and then Kubernetes makes sure that your compute and your storage look like what you've told the API to look like, right? And it's the same kind of thing with Istio. We give you a control plane API, which is basically just it's an API that allows you to define how your network should behave, and it goes ahead and makes sure that the proxies are in the right place and that the proxies are told to route the request in the right place that you told it to do. So you might have noticed this pink logo here next to the proxy. This is Envoy. So Envoy is Istio's proxy of choice. It's so originally it's by Lyft, it's been open sourced and is now part of the CNCF. And really, we just leverage all of the functionalities that Envoy gives us and just make sure it's where it should be, right? All of the most of the features, apart from the key distribution for mutual TLS, is basically just us leveraging all of Envoy's features and providing you with a kind of platform-wide abstraction to be able to configure all of these Envoys. So I think that the reason it's called Envoy, I believe, is because if you go back to this diagram, that it basically proxying requests on behalf or speaking on behalf of all of these services, right? So every service within your mesh, what actually goes over the wire is the two proxies talking to each other. This is typically within the isolated network namespace. So I guess it's called Envoy because it acts as a diplomatic envoy between all of the things. I haven't actually spoken to Matt, who's the original creator, to confirm that, but I think that's kind of how you can think about it, right? They're kind of diplomatic envoys on behalf of your services itself. So what's so special about Envoy, right? Why not use something like Nginx? Nginx already exists. And actually, Istio's precursor, called Amalgamate, which was an internal IBM thing, which was just the traffic routing part of Istio, did use Nginx. When we joined with Google, we switched over to Envoy. There's a couple of reasons for this. The first one is dynamic versus static configuration. So in static proxies like Nginx, you write this nginx.conf file, and then you restart the binary or the process loading in that nginx config file. And that works if you aren't making tens of changes per minute, right? And you don't have to, in a monolithic environment where you've got your monolith and that's always going to be listening on a certain IP and port, that's fine, right? It's not going to change that often. But if you're running in something like Kubernetes, where pods, where different workloads have different IPs depending on when they were started and if they've been killed recently, and it's basically too ephemeral. So dynamic proxies, like Envoy particularly, Envoy basically gets all of its configuration from an API. It's designed from the ground up to be able to handle all of these pod IPs and ports, kind of like popping into existence and then disappearing if you're doing auto-scaling, or if you're just doing a micro upgrade or something. So Envoy is designed to handle this ephemerality by default, and the process architecture, or the threading architecture that underlies Envoy, is designed as though everything's just going to disappear at a minute's or a second's notice, so it can just handle that natively. Now, you can, some of you might say, who are familiar with ingress controllers, but Nginx ingress controllers are a thing in Kubernetes, right? And that's true, although not designed to be run in Kubernetes, you can use Nginx to be your front door using ingress controllers. And the way that works is you have something that basically watches for any changes in the service discovery, and then on the fly will just regenerate the entire Nginx config file and then restart Nginx for you. So it's kind of this hacky way to get Nginx working, and you still have to do the I think it's called hot reload in Nginx. So you can avoid terminating some requests, but fundamentally every time the Nginx config changes, you're going to have to reboot Nginx and load that new config in. And you will also notice that many of the companies in the cloud native area who are writing their own ingress controllers. So you might be familiar with companies like Heptio or Solo, DataWire also doing it. All of their ingress controllers, all of the more fully functional ingress controllers are written in Envoy or use Envoy under the covers. It's not actually using Nginx anymore. And funnily enough, Nginx have noticed this, and you'll start to see that their features are slowly starting to catch up with Envoy's. So talking of features, Envoy, because Envoy is just a reverse proxy, whereas Nginx is a file server that also can be a reverse proxy, Envoy doesn't have to worry about all of the serving files or anything like that. It is purely just a reverse proxy, so it ends up with a deeper, more specific feature set. So in terms of it's all kind of centered around having deep observability into the layer 7 level of your networking traffic. So the idea is, by default, it will do TCP. If it understands the layer 7 protocol you're talking over TCP, then it will be able to read things. So for instance, HTTP2 is one of them. It will look at the, or HTTP1, it'll look at the host headers, it will look at the response codes that you get back, and it will provide you this consistent telemetry on error rates and all of that type of stuff, how many bytes you've sent over the TCP connection, basically everything you can think of, where the request is going from and to at every hop, right? And as long as you're speaking a layer 7 protocol that understands, it can give you that level of detail. So I think at the moment it supports, it does gRPC, it even does native gRPC to HTTP translation. And I know the company that I'm now going to work for put out a blog recently that basically you can define in a YAML how your gRPC definition would map to a HTTP a RESTful API, and it will just, Envoy on the fly it doesn't matter which one you receive, it'll just automatically convert that for you to the one which your microservice is expecting to hear on. So you can even do transcoding between the two. Transcoding is probably not the word. Transpiling. Converting to the one. So gRPC, HTTP2 by default, it'll automatically upgrade. MongoDB it talks, DynamoDB if using AWS, Redis. I think there's work going on Kafka at the moment, so it can speak. Eventually, it'll assume everything that it doesn't understand is just TCP, but then it will upgrade to the layer 7 stuff if it understands it. It also has mutual TLS by default. I think you could probably get Nginx. I don't know if you can get it to mutual. It'd be weird if you had Nginx. Yeah, maybe you can get Nginx to default, but Envoy has MTLS, which is really easy to configure. It's just like one line in config. And then we've got loads of advanced load balancing stuff. So automatic retries and circuit breaking are things you get like with any reverse proxy or Nginx or web server or that type of thing. It does request shadowing, which is basically if you want to load test something you're now going to promote to production, with a production workload, Envoy will split out the request, send one to the thing you're now about to deploy to check that it works, and then when that finishes going down that kind of whatever that path is and returns, Envoy will just dump that request. So you can basically live load balance test with production traffic without affecting any other customer requests, which is a pretty powerful thing you can do. It does things like its own local load balancing, so you can tell it if you have cross data center clusters, you can say these microservices are deployed in this one and these ones are deployed in this one. Try and keep it within the same data center so we don't take the latency hit. If you get to a path where you have to cross over data center, then go ahead and cross over data center, but otherwise keep that latency hit. So you can kind of have all your compute in one place and reduce the latency effects of just hopping data centers as you travel through your microservice request. You can do things like canary deploy and A/B testing, so you can do it based on host headers. So for instance, in the IBM team that I'm working at the moment, we're looking at potentially releasing features only to internal IBM customers. So if we break something, they're the only ones that get affected, and like public paying customers don't. So we can get early warnings on whether something's going to be broken, basically. And finally, fault injection, which I'm going to demo in a bit, but you can basically, I wouldn't advise doing this in production, obviously, maybe in a staging environment, but you can basically say, I want, when this microservice tries to speak to this one, add 10 seconds of delay in there and see if I can if my application will actually handle that, or everything will just fall over and my timeouts don't really work in this sense and that type of thing. So you can do latency and you can do maybe 10% of requests. I want you to 500. And all of this is done without any changing of your code, without any redeploying of your code. You literally just create an Istio config thing and it will configure Envoys to do all this stuff. So these are some of the benefits, but obviously there are trade-offs with everything, right? There are situations where you probably don't need a service mesh and it's probably overkill. So the first one is if your complexity is already manageable. If you've got, and I'm going to use an arbitrary number of maybe 10 microservices, if you've got, maybe you can do it then, but if you've got like a low level of microservices and you have good enough telemetry to be able to effectively debug your application already, you probably don't need something like a service mesh. Once you start getting to a bigger scale and when you're debugging your system and you think, I can't really remember what's talking to what here, and I worked on it like 8 months ago and I can't really remember what it's doing. When you kind of get to that scale, that's when things like a service mesh help. And the reason for that is because the opposite of complexity isn't actually simplicity. At some point, you are going to have to create complexity in your application. It's unavoidable, and sometimes it's completely accidental, right? So the key to complexity is actually transparency. You can deal with a lot higher level of complexity if you can see everything that's going on and it's easy to reason about. If you've got the correct telemetry tools and telemetry information and observability into your application, then you can deal with more complexity. And I'm not saying complexity is a good thing, it is not, but it's unavoidable in most cases. The other one is if you've got no traffic encryption requirements. Now these are kind of separate, right? If you have one of these and you don't have the other, then you probably still should use a service mesh. But if you don't have either of these, so by no traffic encryption, I mean internally, microservice to microservice, you're speaking in clear text. Now, I'd be willing to bet most people are actually doing this, and in my core job, we are definitely not doing this. We are currently moving on top of Istio, so we are going to do this. But once kind of the cloud native ecosystem starts moving towards more enterprisey workloads, that's going to be an issue, right? Because we're having to move to it because we're trying to become HIPAA compliant at the moment, which, for those of you who aren't familiar, is like the health service data protection stuff in the US, all of those regulations. So at some point, we're going to have to start being grown-up enterprise people. So at this point, we're going to start to need mutual TLS and TLS stuff. But if you don't need that at the moment, you probably, if you don't need either of those two things at the moment, you probably don't need a service mesh. The service mesh also does come with a latency hit because we're now intercepting requests at every step. It fundamentally is always going to have one. When we move from monoliths to microservices, there's a latency hit, right? When we move from microservices to then basically having doubling our network hops, although it's kind of over the same machine, so it's not the same whims of like a cross-machine network communication. There's going to be a latency hit. There is some work going on in this, so there are things you can do right now in Istio. So we can do things like global rate limiting across all requests, and if you turn off specifically the policy enforcement stuff, then that will decrease your latency. There's also further work going on in the eBPF area. So BPF is the Berkeley packet filter, which is it's kind of user space networking. I'm going to get this wrong because I understand about 50% of it, and then the rest of it's kernel magic. But the idea is basically when you're going through the proxies, you have to go through the entire TCP stack in the kernel, and if it's on the same machine or if it's in the same pod network namespace, then eBPF can see that and go, oh no, you just want this socket, I'm not going to bother to send you all the way through the stack and all the way back up again. So there is some latency work going on around there, and specifically a company called Cilium are driving this stuff. So if performance is really a concern, I would go and have a chat with Cilium about how you can use this stuff with the service mesh to reduce the latency hit and to increase the performance and throughput of your requests. Ultimately, this kind of all boils down to the same thing with every technology, right? Don't use the technology for the sake of using the technology. You should evaluate that you get enough benefit out of it and for the amount it costs you. And with all technology as well, more moving parts, more things that can break, right? And then more things that you need to learn. So evaluate that you actually are gaining enough from this to use it. Some Istio-specific advice. Istio is modular, so you can, if you just want certain features, and Dan Cerulli, who, I don't know if he's speaking at a GDG event here before, but he's the offering manager for all of the Istio stuff and API Gateway, I think, as well, on Google Cloud. And he did a talk at Istio London called Istio a la carte, which is on YouTube. If you go and search Dan Cerulli and Istio a la carte, you'll be able to find it. And basically it goes through, if you just need this features, these are the bits of Istio you need to install, and if you just need these ones, these are the bits. It's not, you shouldn't, if you're trying to adopt Istio, don't just go and install everything, because it's just going to overwhelm you. Just take the chunks you need. So if you just need mutual TLS, just install the bits you need for that, and if you just need all of the telemetry stuff, just do that. Just minimize kind of the scope that you're trying to get your head around when you're adopting it. And I even take my own advice on this because I'm currently migrating our IBM stuff onto it. and even working on it for 2 years, there are areas where I can't just go in and take every single thing that's available in Istio and know how it all works. So if I've been working on it for 2 years and don't feel confident enough to do it, I'd advise you also not do it. So hopefully now you have a bit of a better understanding of kind of what a service mesh is and when and why you would use it and when you wouldn't. So let's scratch the surface a little and go into some details. So how do we, this is going to be a bit of a Linuxy deep dive and a Kubernetes specific one. So some of the concepts I'll speak about are Kubernetes concepts. So how do we intercept the traffic? In Kubernetes, containers in the same pods are all part of the same network namespace, so they can address each other on localhost. So what we do to intercept the traffic is we run an init container, which basically is a setup container that spins up before the rest of your containers spin up, and we rewrite all the IP tables to basically say any traffic that doesn't come from this PID here, just send it through to the thing that's listening on localhost 15,001. So what that means is when your application makes a request, it thinks it's going directly here or directly here via the maze of Kubernetes IP tables under the covers. But within the pod network namespace, IP table sees this request isn't PID 1337, so we're going to forward it on to Envoy. Envoy will then forward that request on, and once this request leaves this network namespace or this user namespace, it no longer maps to a PID in this contained area, this pod here. So when it comes back in, it's just on a random pod. I think it's on a random pod. It might just be, I can't remember what it does under covers. I think it might just get confused and go, I don't know what PID you're talking about. But either way, it gets forwarded onto the proxy, and then when that proxy makes a forwards on the request, it knows, because its IP tables knows, because this is running as 1337, that it doesn't need to intercept this packet, this request, so it just lets it go onto the container or the service itself. So I said that Envoy just knows where to send stuff, right? How does it know which of these ones it needs to talk to? And that's kind of where Istio comes in. There's an Istio component called Pilot, which is the one I work on mostly. But basically, when each Envoy starts up, it opens up a two-way gRPC stream with Pilot. So Pilot is Envoy's service discovery and configuration API. Opens up a two-way gRPC stream and starts streaming data. Pilot basically then watches the Kube API server for any endpoint or configuration changes that you might have deployed. So if you want to put a network policy in there to do something, then as soon as Pilot sees that that's changed, it will then load that in and make sure and reconfigure all of these proxies to then make them behave how you just asked them to behave. So the security aspects is the other thing that's quite interesting, actually. So the best part about the Istio security stuff is that your applications can just speak HTTP, and when they're actually going across the wire, so between proxy and proxy, it's automatically upgraded to mutual TLS. So you don't even need to manage, if you're doing TLS normally in Kubernetes, you'd have to deploy your own certificates to prove identities of each of these. So with Istio, it does all that for you. That's kind of the thing we do on top of Envoy, as well as configuring it. So your service A and service B in Istio don't even need to care about what certs are, what HTTPS is. It just needs to talk HTTP, and then the platform just handles the rest of it. So it makes a clear text HTTP request. The envoys will upgrade and mutually authenticate with each other. So normally if you're doing TLS, it will be, you're trying to go to google.com, for instance. Your client will basically get google.com to prove that it's google.com. Mutual TLS is the same thing, but both ends. So this proxy will get this proxy to prove its identity to it, and then this proxy on this side will do the same in reverse. So each party is confident it's talking to the thing, something that is who it says it is. So yeah, once this request is made, it will terminate the TLS and speak clear text HTTP to service B. Remember, the clear text HTTP requests here are done within an isolated pod network namespace in Kubernetes. So basically, if you've got something that can listen in on there, you've probably got more problems than someone can listen to your HTTP request, because that will fundamentally mean someone's probably compromised a Kubernetes cluster, and at that point you're kind of screwed. So this is fine to speak in clear text. There are some banks that specifically want this to be mutual TLS as well, so there is work underway to do this. But as a general feature, that's kind of overkill unless you're like a big financial bank that has financial compliance stuff that requires this to be TLS as well. So how does each Envoy actually prove its identity? It uses a component called Citadel. Citadel, this is all again in Kubernetes. If you're interested in how it works, you can kind of ask questions afterwards in things like that aren't Kubernetes based. But fundamentally in Kubernetes, Citadel sits there and watches the API server. It creates a thing called a SPIFFE certificate. That's kind of a special type of X509 certificate. SPIFFE's, I can't remember what the exact term is. SPIFFE's part of the CNCF, but it's a way to prove identity in cloud-based environments. But yeah, it creates a key pair for each service account in Kubernetes, and then we inject it. It stores them in kube secrets, and then we inject or mount the secrets into these proxies when they're deployed. So they've got those certificate key pairs actually available to them, and they just load them in, right? And then Citadel will watch for certificates expiring, certificate keys expiring, and then regenerate them and redeploy them. And then we have a process that sits on the Envoy and watches for like the files actually to change, so we can load those into Envoy when we rotate certificates because they've expired. So this is as deep as I'll go, but these you might be familiar with this. This is an X509 format certificate. We use the V3 stuff, and this is the important thing down the bottom here. Actually, I should probably use the pointer rather than cover all. But we use the V3 extensions, the SANs for it, and what this basically here is, this is the identity that you're proving you're part of. So this is going to be scoped to the local cluster. So this would only work in the cluster where these microservices reside. If you went and spoke to another cluster, it would be a different certificate authority. So it just wouldn't work, right? You wouldn't be able to prove the identity. And this is in the default namespace and the default service account in the default namespace. At the moment, Istio only leverages kube service accounts, which means that a lot of the mutual TLS stuff doesn't work in kind of non-Kubernetes environments yet. But there's work underway where you can do crazy things like verify that the request comes from the specific PID running on the machine that you expect it to be running as, and basically prove that that request is coming from there. Or you can do things like check that the request is coming from a container that's running a specific image digest version. So you can go really low level with this stuff and do some really crazy compliance stuff, like make sure the code you're running is the code you expect to be running and that type of thing. So, demo. Hopefully the internet works. We'll see. We're going to generate kind of 20 requests per second, probably should be fine. So this should be, demo. What we have here is, so this is the Istio CTL proxy status. So these are currently all of the pods, or all of the proxies that are connected to Pilot. So I mentioned there's a two-way gRPC stream. These are the ones that currently have two-way gRPC streams open. There isn't anything actually deployed yet, so I'll explain what those are in a sec. This is just so this is going to go off and install some stuff, but basically this is the Sto Ingress Gateway. So this is basically exposing port 80 to the wider internet, and we have an Envoy running at the ingress, so we can do the request forwarding. So that should now be deployed. What we'll see is all of the proxies associated with the things I just created. That we're going to be spinning up containers, and you'll see the proxies join in a bit, assuming that the proxy status command is actually resetting. 1031 looks about right. So we'll let that go for a bit. Let's go. Okay, we can see one come up. Pod initializing. Okay. So while this is going through, I may as well just wait for it to go through, so let's start. So I've got a script here that's just going to generate 20 requests per second, hitting the front door of this thing using a tool called Vegeta, which is a Dragon Ball Z reference for anyone who's familiar. Okay, so it's pretty much all there. I think I'm missing one, which is the ratings. Details, there we go. Right, so they're all connected, and all of the different Envoy configurations are synced. So let's go ahead and drive some traffic and definitely not take down the internet. We can't handle 20 requests per second, we're in trouble. I need to actually monitor this. So this is actually the front door. Page can't be found, 404 error. It's going well. Oh, I know why. For some reason, the default Istio demo has doesn't work. Just going to that. I should probably set up some rules. Okay, so this is a very boring book info app with some super secure clear text cookie sessions, and we're driving load. So if I refresh this, we should see error fetching Grafana. That's fine. So these are requests coming through. We'll get response time, percentiles in there, traffic animation. So what's important here is that none of this stuff is actually, all of this code, none of it knows it's in a service mesh. It's not exposing any of this telemetry like by default. It just gets this as being deployed on the thing. And what this is actually doing is, we use Prometheus to scrape the envoys and do some mutation using an Istio component. And basically, this is a thing called Kiali. It's done by Red Hat, actually. And this just is backed by the Prometheus that we're running in the back end. So there's some requests. We've got some requests per second coming in. Let's should probably do it on here, so we're not. Right. So what I'm actually going to do is specifically Injector Fault. So I have a fault injection here. This is Istio config, so we're basically just saying anything that goes to the detail service, maybe for 10% of the requests, inject a 2-second latency into all the requests to see how my application handles it. So I will comment that out and redeploy. Again, this is all done without any, this is all done with config changes, right? It doesn't require redeploying any of my code. It doesn't even require my code knowing what's happening. So what we should see over time is see this start slowing down. We're already starting to see some failures here. I'll go and show you in a minute why we're seeing failures there. But eventually this will start doing 10% of requests taking 2 seconds, so we'll start seeing this ramp up. I will show you why it's failing, so we can go in here and look and say, at the moment we're at about 2.8%. I can't quite see where my refresh thing is because it's just off the side here. It should refresh every few seconds. But this will start going up until eventually we reach 10%. So what this kind of tells me, and it tells me this because I know because I've already looked at the configuration, but if I was debugging this, what this would tell me is that we're starting to see an increase in latency going between these two things. This here is increasing in latency, but not to the level, if I zoom out, of what this is. So this is now up to 1.58 seconds, which a minute ago it was running at what, 20 milliseconds, right? So clearly there's something going on here. Now it's going on there because I broke it, but the concept is the same, right? If one of your downstream dependencies is just added 2 seconds of latency for some reason, it's going to be the same type of thing. So why we're getting the increased error rates here, so we're up to about 10% now, so that's about right, is because it's the front page, we have a really stringent timeout set, and the timeout is set to 0.5 seconds here. So the fix, this is obviously a very contrived example, but the fix would either be you take the timeout here and you don't time out after 2 seconds, or you fix whatever the downstream dependency is, right? I'm just going to comment it out to fix it and to do a very contrived demo, but fundamentally you can change, you can basically do whatever you want, right? You could increase timeout, you could fix your latency, you could probably introduce some retries here, so because we know only 10% of the requests are failing, within config here, which I believe is at about this level, you could say, just can you retry twice, please? And if you're unlucky enough to hit the 10% 3 times in a row, basically, then you would still 500. But 3 times in a row, even if you hit the timeout of 0.5 seconds, is still less than the 2 seconds. So cutting it off short and retrying, because it's way over the expected latency, will get it to return quicker than the 2 seconds latency there, right? Because it'd be 1.5 seconds at most. it's all kind of up to you how you actually want to fix it, right? But if I go down here and just magically fix my dependency so it's no longer delayed, I've got 2 seconds of latency and redeploy, we'll just see Kiali go back and be a bit more healthy. So we'll deploy that. So, mind the way, we will, I will put that back up in a sec, but I will, while I'm finishing. Basically, so that's the end of the demo. In terms of, let's go back to present mode. So, if you've got any questions, happy to ask them. If we go over time and you want to speak to me outside, happy to help them. If you're interested, or if you're currently doing like multi-Kubernetes cluster deploys and you want some way to kind of manage them and visualize them using something like a service mesh, then also come speak to me afterwards, because that's of interest to my new employer. But yeah, if you've got any like ideas for how Istio can be, or we can improve the debugging experience, then I'm open to them. If you've got any insults for me on the Istio debugging experience, happy to hear them as well. And yeah, thank you for listening. Hopefully this is
20 minutes before the next talk starts. I mean, has anyone got any questions for me?
I got lots of questions.
Yeah, which is fine.
It was a great talk, by the way. Thanks. This was very good. Just to get my head around the number of reverse proxies that we can. Let's say you have 100 deployments, 400 pods, 50 services.
Yep.
I'm about 50 reverse proxies in that setup?
It would be a proxy for every pod.
Every pod, so
Yes.
400 proxies on every node.
Envoy's really good actually, because the memory footprint of Envoy is pretty low. It's less low in an Ingress Gateway because we have to load a load more config in there. But I think we limit all of them to like 10 meg of RAM. It's really low, like it's really low level C++ stuff. If you're really interested in going deep into it, there's a talk at KubeCon by Matt Klein, who did a really deep, like how it can do all of the quick like loading of all of the config and how it managed to keep this really low level footprint. Most of it went over my head, I'm not gonna lie. I maybe understood about 40%, and then he started talking about like threading algorithms and stuff, and I kind of just went, but it's really interesting, the parts that I understood about how it keeps it all kind of really small footprint. And actually, Linkerd, which is also another service mesh, have recently moved over to a similar model of a sidecar proxy, and they had to rewrite their entire proxy in Rust because they were doing it in Java, and you cannot put a JVM in every single pod because you just would run out of memory, or you'd have to spend so much on RAM that you would never be able to do it. So it's the key with the benefit of using Envoy actually is that it's so low that it's the memory usage is so low we can't afford to deploy them everywhere. Now there is going to be a memory hit. Right?
Is there other numbers? Like is it 10%?
I can send you a document. I don't know the numbers off the top of my head.
Right.
I can send you. There's a whole report that Google and IBM did that is basically they went and they hit I think 10,000 pod clusters with. They did turn some of the Istio stuff off because obviously. We can't. It's a relatively early project, right? We can't afford to. In Kubernetes, everything can talk to everything, so we've got to load every single thing into Envoy because we don't necessarily know what's being sent where. We have to be able to send it everywhere. So there is some work underway to minimize this, but at the moment, although it's like it was like I think 10,000 pods, and they hit it with a certain amount of RPS, and it was still holding up, and then it starts to tail off after a while. But there's like a full report on the memory usage of each of the things there, like where the memory, they did analysis on what functions within what things are using all the memory, so we know which bits we need to optimize, and there's work going on for that. But yeah, I can find the link to report.
And the same mean the latency will also take a hit, right? It's probably some. In that
yeah, you're always going to take a hit because you're going through a reverse proxy at each level, and maybe if you're doing flash trading, right, in banks, probably don't want a service mesh because you can't afford that latency hit. But for most people, being able to debug stuff when it goes wrong is value, right? And that's far more important than maybe 5 milliseconds of late. I can't remember. It depends like what scale you're doing it at, right? And the latency will depend. But that's much more valuable than the latency here. And like I said, Cilium are doing some eBPF stuff where because they can detect that the proxy and the container that's making the request are running on the same machine. it doesn't need to go all the way through the kernel stack to make that TCP request. It just goes, oh, you mean this thing in user space, and just, I think it's in user space, and just goes, yeah, I'm just going to hook you up to here, and kind of bypasses the entire kernel stack. And I think even in there's been some TLS stuff added recently, so you can even do TLS handshakes across like the eBPF stuff, I think, coming down the line. But most of that I'm kind of doing hand wavy. I know it's there and I know what it does. I don't really understand how it works.
How do you spell it, Cilium? I was trying to find it.
C-I-L-I-U-M. Yeah, they have a couple of talks on doing Istio specific stuff. But yeah, it kind of works as the networking layer underneath Kubernetes and Istio, right? It works at the kernel level and makes sure that everything's not doing something dumb like going, if it can keep it within the same thing, it can keep it within the same thing, right?
I got a few more questions. I'll pause
yeah,
for
we
others
speak
to-
afterwards.
again.
Anyone else with questions? Yeah.
Debugging question.
Yep.
So hopefully you're how much info can you get out about the failures? So you can see some of the number of different status requests that come back. Can you, for example, get it to scrape out a bit more of the info that the response has come back, or this is the body that's been sent over for some of the failures?
Yeah, I'll let someone else speak while I'm trying to port forward to Grafana, and then I'll show you all the Grafana stuff. But I'll take someone else's question while I'm working out how to port forward.
I have a question, maybe easier. So if I'm deploying onto Google Cloud or Google App Engine,
Yes.
and it's going to be, because you said Istio is basically a platform
Yes.
solution. So is there any point me trying to like use gRPC or any other sort of like TCP framework on Google App Engine, or should I just say, just make an HTTPS request, and I know underneath the covers it's going to be upgraded to me?
Yes. So App Engine's slightly different, right? Because it's not, you don't have as much control. It's more of a PaaS type thing.
Mhm.
I mean, I know Kubernetes is technically a PaaS-ish type thing, but App Engine would require, because you don't manage enough of it, it requires Google to go and do something like a service mesh under the covers. So if you look at if you can find some of the work Cloud Foundry are doing on it, which is kind of the same level of abstraction as App Engine, right? And Cloud Foundry are starting to leverage Istio and Envoy to do something like this. It wouldn't surprise, I don't have any specific information on if Google are doing something like this, but it really wouldn't surprise me based on the amount of Google contributors there are to Envoy if they were looking at plugging something like this into App Engine to expose a kind of the exact level of metrics, the same level of metrics for App Engine users. But I don't have any information on that. So
I have a related question that's similar to the App Engine. That's an external service, right?
Yes.
How would you bring that into the Istio?
So
Mesh?
is it an external service you own, or is it like, you're running a monolith in another?
No, let's say you have a bunch of
cloud?
microservices, but you
Yeah.
need to talk to an App Engine API.
Yes.
Or an application running an App Engine.
Yes.
Or something else. Yeah.
So again, that would require Google to basically build. It would basically require Google to, under the covers, do something with Envoy. Right,
There's
in
no
order
way to
get
create
those.
like a proxy for that in Istio and say just talk to it externally and give me the metrics from it.
There kind of is. So you can do TLS origination with external services, right? So you can tell the Envoy that I'm trying to speak to I'm just going to use like google.com/API or something, http.google.com/API, and once it reaches the point at which it exits the mesh, it can tell Envoy to make sure you just do simple TLS, like one-way TLS, and you won't be able to see both sides of it. You'll be able to see what's leaving your mesh, and you'll be able to see what's coming back. Whereas if you've got meshes with service to service, you can see leaving it, crossing, going back in, and you can see it going back in and going across and back in. You'll just be able to see entering the proxy. You'll still be able to see all the HTTP layer 7 stuff, and at that point it does TLS origination, talks to it on behalf of it, comes back, terminates the TLS, gives you all the metrics of the HTTP request coming back, and then forwards it onto your application. So,
Got
this one.
4 minutes.
Right.
Have a chance to move.
What's default? 3,000, 30,000. So port forward is definitely going to work over a network, isn't it? CC/Grafana. Linux. Namespace. Every time it gets me. Too many zeros. Alright. So hopefully. So this is just Kiali, right? This is just the service mesh tool that Red Hat have built on top of it. If we go to, hopefully this works. I haven't actually tried to verify that the Grafana stuff's up and running. It's going very speedy. My port forward is not working.
We loaded, gave an error on
It did the first time. Oh, I know what I'm doing. It's because I need localhost, don't I? 7.0.0. I'll show you the stuff afterwards, but you basically you can break it down from service to service. So recently, actually it was quite funny with Istio, we're doing perf tests against it in dev with the registry code. So I work on the container registry team at IBM Cloud, and we found some errors that we didn't see before running a perf test, because we could actually see that we could drop to 10% success rate going from one microservice to another, whereas, so we had service A to service B was at 10%, and service C to service A was still at 100%, and you can go into Grafana and physically break down that there were 5 services making requests to this backend service. Can I just see each one of them, please? And it's all just kind of built in, scraping the Prometheus stuff under the covers. There is one of the components of Istio is called Mixer, which acts, you can plug it into things like Stackdriver if you use Stackdriver, but the idea is Mixer can provide an abstraction over whatever kind of telemetry infra you're using behind the covers. So you could just change a config in Istio and it would spit it out to Prometheus or Stackdriver, or I think Datadog have a thing as well. There's quite a few companies that have started building adapters basically that allow you to export it to kind of whatever backend you want. I'll show you that after if you're interested. So yeah, how long have we got? 1 minute.
Does it work with overlay networks? So Calico or something?
Yes, yeah. Calico are actually actively involved in Istio stuff as well. So they're writing a load of, because Calico's layer 4 networking policy, they're also writing some layer 7 stuff into Istio, so you can say things, you can even do things like only things with this specific host header from this specific microservice can talk to this type thing. So they're starting to move up the stack to the layer 7 stuff. And it requires that it's similar to Kube, right? It just requires all your microservices can talk to all of the other ones that can be discovered within whatever bounded cluster you're doing, or whatever. And you can even do cross-cluster stuff as long as you hook it up the right way, basically.
Right then, we're at 10:50, so thank you very much, Liam. Wish you everyone